to True Projects. In this video, we are going to explain about a project titled Anemia Detection Using Machine Learning. So now coming to the introduction part. Anemia is a common world health concern marked by a shortage of red blood cells or reduced capacity of these cells to transform oxygen. Swift identification and treatment of anemia are vital to avoid serious health issues. Conventional approaches to detecting anemia frequently require blood tests and manual inspection, which can be both time-intensive and expensive. The incorporation of machine learning methods has presented an encouraging option for swift and precise anemia detection. So now coming to the objective part for this project is to enhance the precision and speed of the diagnosis. Anemia is a complex condition stemming from various causes, and its symptoms can mimic those of other health problems, rendering it a difficult ailment to accurately identify. Machine learning models can be instructed to scrutinize a wide array of patient information, including medical records, test results, and even imaging data in order to identify subtle patterns and relationships that might elude human evaluators. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and Seaborn for visualization are important. Next we have exploring the dataset anemia data. In this step, the dataset related to anemia is loaded and examined. Data exploration includes checking the structure, summarizing statistics, and understanding the features in the dataset. Then we have data processing. Using Pandas data frame, data pre-processing involves tasks like handling missing values, encoding categorical variables, and scaling or normalizing data as needed to prepare it for analysis. Then we have visualization using Seaborn and matplotlib. Data visualization is performed using Seaborn and matplotlib to gain insights into the dataset. It helps in understanding the relationships between variables and identifying patterns or trends in the data. Next, here we have feature selection. It is the process of choosing the most relevant features to columns from the dataset. This step can involve model performance and reduce complexity. Then here we have building the model. This step involves creating and training machine learning models for anemia prediction. Common models mentioned here include linear support vector classifier, that is linear SVC, then random forest, decision tree, and Gaussian naive Bayes. Additionally, ensemble techniques like stacking classifier and voting classifier, a combination of random forest, PAC, and boosting are explored. Then next here we have training and building the model. The selected machine learning models are trained on the pre-processed data to learn from the patterns in the dataset. Then we have training the model with k-fold validation. K-fold cross-validation is a technique used to assess the model's performance. The dataset is divided into k subsets and the model is trained and tested k times, with different subsets used as validation data each time. Then we have Flask framework with SQLite for sign up and sign in. This step suggests that a web application is built using the Flask framework with the SQLite database integrated for user sign up and sign in functionality. Next here we have importing the packages. Similar to step 1, this step reiterates the import of necessary packages for the web application such as Flask and SQLite libraries. Then we have user gives input. In the web application, users can provide their input or data relevant to anemia prediction tasks. Next here we have the given input is pre-processed for prediction. The user provided input is pre-processed and prepared for prediction by applying the same data processing steps used for the original data. Then we have trained model is used for prediction. The pre-processed user input is fed into the trained machine learning models to make predictions about the presence or severity of anemia. Last one here we have final outcome is displayed through frontend. The prediction results are displayed to the user through the web application frontend, indicating whether anemia is likely or not based on the provided input and the trained model's prediction. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then we have .ipy and file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Then we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. Next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the class framework will host the application link locally at the default address and port 5000 unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is the home page for the anemia detection using machine learning. Here is a button for sign up. Just click on this button. Enter your username, name, email ID, phone number and password over here for doing the registration. I have already done the registration, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration and simply click on submit button. So here you have to enter your age, gender, enter RBC, PCV, MCV, MCH, MCHC, RDW, TLC, PLT, HGB and click on submit button. So the outcome is showing that the person is not affected with anemia based on the input. So depending upon the parameters you are entering over there, it will detect whether the person is affected with the anemia based on the input provided or not. So here you can see that there is a button for about. Just click on this button and here you can see that there are many different graphs where we have used many different algorithms and based on the algorithms we have got the accuracy, precision, recall and F1 score. Here you can see that there is a button for sign up. By simply clicking on this button you can successfully log out with this. So now coming back to the conclusion part. To sum up, the incorporation of machine learning in anemia detection presents a substantial opportunity for the healthcare sector. Applying machine learning algorithms provides a more accurate and streamlined approach to anemia diagnosis, addressing a condition that has a global impact on billions of individuals. Through the adoption of these advanced technologies, healthcare practitioners can enhance diagnostic precision and accelerate the diagnostic procedure, ultimately resulting in more timely and efficient patient care. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.